Okay, today we're going to talk about net forces. Net forces are kind of a bridge between our past and our future when it comes to talking about Newton's first law and Newton's second law. Now, in the past we talked about Newton's first law, and Newton's first law says that forces are balanced when velocity is constant or acceleration is zero, and forces are unbalanced when velocity is changing or acceleration is not zero. So when things are all kind of moving along at a constant speed, things are balanced, but if they're speeding up or slowing down, it's unbalanced. And in the future, we're talking about Newton's second law itself, which is all about how mass and acceleration affect force. Okay. So the question is, what is a net force? A net force is basically what happens when you add up all of the forces. It is the sum of all forces. Okay. So, take a look at this. So, what are we going to do with net forces? We are going to quantitatively determine if forces are balanced or unbalanced. And here's another vocab word for you. It's our second one. The first one was net forces. Our second vocab word is quantitatively, and what it means is that we are going to use numbers. We're going to use numbers to determine if forces are balanced or unbalanced. Now let's get to work. Okay, now when we talked about Newton's first law, we said that balanced velocity is constant and acceleration is 0 meters per second squared. If things were unbalanced, velocity was changing and acceleration was not equal to 0. So that's velocity and that's acceleration, but we're talking about forces. So if velocity is a constant number, or acceleration is 0, or velocity is a changing number, or acceleration is a number, it's not 0, what kind of number are forces? Okay, if you kind of think about it, you can almost figure this out intuitively. Think about forces are balanced. Okay, so you're balanced. So you've got the normal force of something holding you up, and say normal force of something is holding you up, and we've got the force of gravity that is pulling you down. Okay, all right. The normal force is up, the force of gravity is pulling you down. You're not going up, you're not going down. So that means that if you were to add them up, all of your forces together, the sum of these forces would equal 0. This is balanced. Okay. Now, on the other hand, if you've got unbalanced forces, okay, if you add up all of your forces and you look at it, they're not going to equal 0. If the forces are unbalanced, that means some force is bigger than another. So let's say if you're sliding down the surface, all right, you've got some sort of force that's pushing you to the right. You're shoving a book down. And then you've got friction over here. Well, you're still moving, which means that your applied force is going to be bigger than your friction force. So if you were to add these forces up, okay, if you were to add these forces up, it would not equal 0. Okay? This would be unbalanced. Okay. All right, you guys see that funky little sign I'm using? Okay, what's that funky little sign I'm using? It is called a sigma. Sigma, sigma, sigma. All right, it's called sigma. And sigma basically means add up, total, sum. That's what it means. So whenever you see sigma and some variable like, say, sigma f, what you're really saying is add up all the forces, and that's exactly what we want you to do. All right. So now before we start calculating net forces and really working with that, I want to remind you guys that forces are vectors, okay? And what forces are vectors means is that it matters which way you're going. So let's say you're standing on the edge of a cliff. There I am, waving. Don't laugh at my stick figures. All right. So you're standing on the edge of the cliff. It matters which way you're going. If somebody pushes you to the left, that's going to be a really different result than somebody pushes you to the right. And so with vectors, we say whatever that direction, we use that direction to go ahead and add in, or rather to include a positive or a negative. And that helps us tell which way things are going. So we generally say that if things are going to the left, it's negative. If things are going to the right, it's positive. Also, if things are going up, positive, and down, negative. Okay, so I'm going to clear this off and we're going to start doing a couple of different examples. Okay, now we're going to go ahead and we're just going to have it, oh look, we have a rock. The rock is sitting on the ground. So what are we going to do with this rock? We're going to figure out what are the forces. Okay, well, on this basic rock, the forces that we have, we're going to have gravity pulls this rock down, and the normal force that is exerted on the rock from the earth is pulling it up. Okay, and they should really be about equal. Okay, so we get the force of gravity pulling it down, and the normal force is holding it up. So let's say that the force of gravity is 10 newtons. Well, that rock is neither sinking nor rising, so that means that the normal force also has to be 10 newtons. So let's go ahead and we're going to do the math here. So what are the sum of our forces? Okay, some of our forces is that we have 10 newtons, we have positive 10 newtons going up, and we have negative 10 newtons going down. So if we were to add this all together, we would get 0 newtons, which makes sense. All right, because it's neither sinking nor rising. It's not moving. Velocity is 0, so it's balanced. This is balanced. Okay, here's the second example. Notice I've taken the other first one and I've kind of put it up in the other corner. I've kind of redrawn it a little bit. So the same situation, we have a rock that is sitting on a surface. It is given a push into the right. We're going to call this an applied force. We're going to use the same numbers that we had earlier. Normal force is 10 newtons. Gravitational force is negative 10 newtons going down. And our applied force to the right is 10 newtons. Okay? So we're going to add up our forces. When you're adding your forces, you only can add forces that are in the same axis. So that means we can add these guys up. All right? But we have to only add those two guys together, only in the y-axis. All right? So we're going to add those guys together, same thing that happened in our first scene. We've got the sum of our forces will equal 10 newtons. All right? Minus 10 newtons. Notice what I've got over here. I added that y. Okay. I added that y again because, well, I'm adding the forces in the y direction. So 10 newtons minus 10 newtons is equal to 0 newtons. So now let's go ahead. We're going to add up the forces in the x direction. Well, there's only one. All right. So now we take a look at our forces. Well, are our forces only 0 anymore? No. All right. Because this x force right here, all right, because that has a number on it, that means that our rock is accelerating. And what do we call it if things are accelerating? We call it unbalanced. Okay. Yay, unbalanced. So now you have two examples, one balanced and one unbalanced. All right, and now we're going to take our attention down to the bottom left-hand corner, where we see same situation again, and now we're going to add another force, where scenario number 2 had no friction. Okay, the scenario had no friction. Now we're going to say that that force was applied, but there was additionally a force of friction that is going to the left. Right there it is. Okay, so now let's go ahead. We're going to say all those forces, same ones we had earlier, they're in here. Normal force and force of gravity are both 10, 10 up, negative 10 down. Our applied force is 10 newtons, and let's say what happens if that applied force of 10 newtons is is being pushed at 10 newtons of force, but there are 10 force of friction is going to be 10 newtons as well. Okay, so it's 10 newtons, but because it's going to the left, it's a negative 10 newtons. Okay, which is the exact same thing we did earlier. We're going to take the sum of our forces, and we're going to take the sum of the forces in the y direction. Okay, all we have in the y direction is we have our normal force going up, and our force of gravity going down. 10 newtons minus 10 newtons equals 0 newtons. Same thing, see what happens with our x. Okay, sum of our forces in the x direction. All right, this is going to equal our applied force, and it's going to be applied force to the right minus our force of friction to the left, and that becomes 10 newtons minus 10 newtons equals 0 newtons. So if both our y and our x are 0, they're both 0, what do we call this? It's balanced. Okay. If it wasn't already moving, it wouldn't be staying still. All right. This means it's either going to continue moving at a constant velocity or stay still. There will be no change of velocity here. Okay. And fourth scenario. Again, we're going to have that applied force. Okay. Normal force going up, 10 newtons, and we'll have normal force going up 10 newtons, force of gravity going down. The applied force is going to the right. Only thing different that we're going to do here is that instead of having a 10 Newton force of friction, well, let's say that we have a 5 Newton force of friction. Okay. There's our force of friction. Let's go ahead and we are going to add in some of these values. Newton force, normal force is 10 newtons, gravitational force is negative 10. We'll have the applied force is 10 newtons, and our force of friction will be, we just said 5 newtons. Sorry about that, a little bit of a typo. Okay, let's move on. We're just going to keep putting our stuff in here. We're going to say that the sum of the forces in the y direction. All right. Well, from previous examples being, hang on one second, previous examples being here, here, and here. We think it's pretty safe to say that 10 newtons up and 10 newtons down is going to give us a force in the y direction of 0 newtons. And for our forces in the x direction, okay, again, we've got the applied force is positive, it's to the right, and our force of friction is negative, it's to the left. So we've got 10 newtons minus 5 newtons. Put those values in, and our forces in the x direction, oh, not 0 newtons, it is 5 newtons. Balanced or unbalanced? That's right, unbalanced. Okay. All right. Okay, give it 1 second. We're going to have one more example. Okay, this is where we last left you. Exact same scenarios we had before, but we're going to do one more thing. What happens if, in addition to that one force that's going to the right, we have another force going to the right? What if we have a second applied force to the right? Do a little bit different here. There we go. Okay. The second applied force to the right, how much do we want to give it? Let's say it's FA2. And we're going to say this second applied force has a value of 15 newtons. What do we do with it? All right, let's go on back up. Same math as before. We can say, we've already done it like 5 million times. If they're the exact same forces, they're their opposite exact value but opposite directions, the sum of our forces in the y direction is 0 newtons. 10 newtons up, 10 newtons down equals 0 newtons. For our x direction, though, what we're going to get is we are going to get 10 newtons, applied force 1, plus, because it's also going to the right, are 15 newtons in the right direction, and that'll be minus that 5 newtons. Okay? So 10 plus 15 is 25. 25 minus 5 is 20 newtons. Okay? So whenever you've got more than one force, you just include it. Is it being added or being subtracted? And there you go. So hopefully this made sense to you, and you can follow along with this. There'll be another sample, 2 more sample problems on the next page, and you can do those at your leisure. All right, thank you very much, and we'll see what's going on next. Oh, and don't forget, this is definitely an unbalanced scenario. And finally, here are your sample problems. Samples A and B are simply calculate the net force. On A, you've got a 12 newtons force to the right, a 5 newton force to the left. Calculate that net force and include the direction. For B, you're going to calculate the net force and include the direction. If you have 7 newtons going up, 3 newtons going down, and a second 4 newtons going down. Problem C. A skydiver is falling toward Earth with a force of 730 newtons. There are 75 newtons of air resistance slowing her down. Draw a free body diagram and calculate the net force. Oh, fixing the grammar, just 1 second. Alright. Finally, D. Use 4 forces to create a free body diagram with a net force of 2 newtons. All you can do in that one, guys, is you're just going to draw what the free body diagram would look like and give me the values of the forces so that they equal 2 newtons, so the net force equals 2 newtons. And that's it. All right, enjoy yourself, guys.